In this video, we're going to take a look at factorizing using the difference of two squares method. Now, if I've got the difference of two squares, I must have two terms. Difference means that they must be separated by minus, and I am going to split each term so that it is the root of the original expression. When I do this, I must create two brackets, one bracket with a plus, one bracket with a minus. And now I find the root of x squared, which is x, and I find the square root of y squared, which is y. Let's try this concept in another example. I once again have two terms separated by a minus. If I want to do the difference of two terms factorizing, I'm going to split these into two bracket factors, one bracket with a plus, one bracket with a minus. Now I'm going to concentrate on the 4x squared first. When I square root that, then I must find the square root of 4 and then the square root of x squared. Well, the square root of 4 is easy because that's a perfect square, so that's going to be 2. When I want to find the root of x squared, I divide x's exponent 2 by 2, and so I get x. So the first term in each bracket is 2x. Now take a look at the next term. I'm going to deal with the numerator first, because there are factors in the numerator and factors in the denominator. The root of y squared is going to be y, and now dealing with the denominator, the square root of 9 is 3. By breaking this down into smaller parts, finding the difference of two squares was not half as difficult, so you don't need to worry about seeing fractions anymore, so long as you deal with the concept part by part. If I had multiplied out these brackets, I would in fact have got my original expression again. But the point of factorizing is to change my expression from terms to factors, which I have successfully done. This example looks a little bit more difficult, but what you have to recognize is that a bracket factor, when worked with, works exactly like a variable factor. Now let's check and see if I in fact can do the difference of two squares here easily. Well, I do have two terms. They are separated by minus, and in fact every single one of these factors is a perfect square, because it's the bracket squared. 25 is a perfect square because it's 5 times 5, and y squared is definitely a perfect square because it has an even exponent. So I can very nicely break this up into two brackets. Remember, the first bracket has a plus, the second bracket has a minus. Now if I have got two bracket factors, and this has been explained with this exponent over here, then I must split those bracket factors so that half of them are in the first bracket and half of them are in the second bracket of my factorized expression. Well, as I've got two brackets, I must put one bracket in the first term of my first factor and one bracket, exactly the same bracket, take note, in the first term of my second factor. As the original bracket of 2x minus 1 was repeated twice, 2x minus 1 goes into the first place of each of those factors. Now going to the second term, this is easier again, because what is the square root of 25? 5. And so I can put that as the first factor in the second term place. And what is the square root of y squared? Well, that is an easy one too. That is y. But what would you have done if you got something that looked like this? If I'd look at this expression, I would probably have told my teacher in core maths that I cannot find the difference of two squares because this is x to the 1. But actually, if I want to do the difference of two squares, I just need two terms separated by a minus. Watch what I'm going to do. As I have got these two terms and they're separated by a minus, I'm going to create my two bracket factors, one with a plus, one with a minus. Now, as the square root of 1 is easy, I could have done that one very nicely. I told you that you need to split the x factors so that you've got half of them at the front of the first bracket factor and half of them at the front of the next bracket factor. Now let's just look at this on the side. If I have got x to the half, and that is times by x to the half, haven't I actually got x to the 1? So in fact, what you're going to write in each of these is half of the x factors that were given to you. And as you were given one only, you have x to the half at the beginning of the first bracket and exactly the same amount at the beginning of the second bracket. You might remember that if I write x to the half, that actually means x to the 1 square rooted. And so you can see by me writing it this way that I could have written x to the half plus 1, x to the half minus 1, or in fact the square root of x plus 1, the square root of x minus 1. And I would have had the exact same answer. If I had tried and multiplied out these brackets, I would in fact have got my original expression of x minus 1 again.